Welcome, everybody. We'll start here in a minute. All right. Well, good morning and good afternoon. My name is Stephanie Span. Today's webinar is sponsored by the network of the OSHA Training Institute Education Centers. Before we get started, we are going to go over a few housekeeping items. First and foremost, we invite you to use the Q&A function to ask us questions. We will compile these questions throughout the program and answer as many as possible by the end of the webinar. This webinar is being recorded and will be made available to you to share, as well as the slides of the presentation will be made available to you. Unfortunately, we cannot allow to give CEUs or certificates of any kind. Please understand that this is informational only, and we hope that you still enjoy the next hour with us. If you are here for the duration of the presentation, we will have a short 1 to 2 minute survey for you, and more details will follow towards the end of our presentation. So thank you for joining us today, and I'd like to turn the presentation over to Albert Anthony, who will introduce our speaker. Thanks so much.
Hello, everyone. I'm Albert Anthony, one of the directors for the OSHA Training Institute Education Center based out of Louisiana. Our speaker today is Aaron Mars. Aaron is an instructor with the Mid-South OSHA Training Institute Education Center. Aaron leverages his extensive experience, deep knowledge of regulatory standards, and expert-level adult learning methodologies to effectively engage learners and optimize information retention. He specializes in teaching occupational safety and health administration standards, as well as OSHA Training Institute Education Center instructor courses that emphasize rigorous job hazard recognition, compliance standards, and safety policy. Driven by a commitment to workplace safety, Aaron plays a major role in equipping industry professionals with the critical skills needed to excel at the highest level in OSHA-regulated fields and other strictly monitored industries. I will now turn the presentation over to your speaker, Mr. Aaron Mars.
All right. Thank you, Albert. I appreciate that. Just very humble. Happy to be here today. That was a great introduction. Thank you so much. I'm gonna go ahead and share my screen so that we can go ahead and get this thing kicked off. I've been chomping at the bit to get to this day, and I'm excited to be here. Very excited to be here. Just because, I didn't see this part of my life, right? So we want to make sure we understand we get a chance to have moments in life where, things that we didn't necessarily plan on having or seeing, we want to take full advantage of that opportunity. All right, so we're going to talk about fall protection today. That's what we're going to be talking about. And I'm going to dig into like certain things that we're going to talk about, but just a little bit about me and who I am so that you got the nice introduction. But to give you a little more depth, I've had a lot of seasons in my life of hard work, seasons of desires for something that developed passions in my life. I've had some seasons of overcoming adversity, as well as redirection and purpose and alignment with that purpose. And so these things just kind of culminate that cyclical process of these seasons that are taking place, and nothing has happened all at the same time. It's all in one thing. It's not linear. Different areas of my life are going in different places. In one area of my life, I might be in the desire time, or I might be in an adversity situation in another area. So this all stuff that comes together that has shaped and formed me over the years. All right. So I appreciate everybody's attention today. And my goal really in life and what I do is to serve humanity. I want to serve humanity. I want an opportunity to whatever you come for, trying to get transformation in your life, I want to make sure that you get that. All right. So that's what we're going to be doing for today and how we're going to move forward. All right, so I always like to, anytime I'm doing a presentation or any type of informational, I always like to start with a problem, right? Because I'm a firm believer that, good questions, especially the ones that you don't have the answers to, are what progress the world forward. You've seen that, with people like Steve Jobs and others in the world that have created things that today we use on an everyday basis that didn't exist before. And so when I think about, the highest level of creativity, I think about the fact that it starts with a good problem, and then obviously some questions that go with that problem. So one thing that I've identified over my years of doing work, and I come from a construction background, construction safety. I was a director of safety for about 12 years for that construction company. Worked in a lot of different environments between construction, general industry, and I saw a lot of different things, especially related to this fall protection subject. And just over the course of those years, pondering and writing things down and just having questions of my own, I've kind of formulated this problem that, when we think about fall protection and why we still experience the incidents today in the workplaces around falls. I think of the fact that organizations experience fall related exposures because work systems are frequently challenged. And, when we think about those challenges, I look at like, what is it? Changing conditions, human variability. That's probably the biggest piece right there. We do rely a lot on our humans to perform a certain way. And this is why we do training and why we have education. I mean, we always tend to kind of get back to that place of, well, if the worker would have done something different, then maybe, we definitely would have had a different outcome with that. So that human variability. I also want to talk about operational complexity as well. These things, I was in a class yesterday and one of my students was talking about the fact that, sometimes, especially in construction, you just have a really complex situation. You don't always have what you need, but because of the pressures and the deadline that's placed on getting the work done, and it just becomes a very complex situation. Things change faster than the protective controls are designed, recognized, and adapted, and to manage those things, those changes. And so these are things that I've kind of looked at as problem areas as it relates to fall protection. And so we're going to unpack this problem today. I have a couple of situations real situations that have happened to people, unfortunately, and we're going to look at that and see how can we solve this problem and all of our problems going forward as we continue to create this improvement loop that we have going on in our organizations. All right, so I want to just turn your attention to the National Safety Council. So the National Safety Council is a great resource. They pull information from the Bureau of Labor Statistics, which they get their information from the OSHA record keeping, and they're able to compile it for us professionals out there, and we can see exactly like what are the stats. What are some of those lagging indicators that we see or that we've experienced, as a nation, as a whole, as it relates to certain, just workplace conditions, right? So when I went and looked up falls and saw that, it immediately brought my attention to the fact that we had 5,070 workplace deaths in 2024. That was the count that happened in 2024. 17% of those deaths were falls, right? They accounted for, falls accounted for 17% of that. So that's 866 falls that were, fatal falls. Out of that 866, 145 of those falls were falls to the same level. So we're talking like, I'm standing on the ground, moving along, I trip over something and fall to the level that I'm walking on or my walking working surface, and it creates an injury that I pass away from, right? And so that's alarming. I think that's extremely alarming. I don't, and when we think about fall protection, we kind of just I say our mind shifts only to working at heights or working from a temporary elevated work platform or unprotected sides and edges that are, subject to a lower level, but falls to the same level are killing people too. And so we got to be aware that this is a holistic thing that we got to really look at as it relates to falls. And I'm gonna just say this because you know, I don't care about how many people are in the workforce and how many millions of people are in there and how 5,070, compared to that number. What I think of is that one family, and if you've had a situation, that you've ran into in your life where you've experienced this, where someone that you know or someone that you've been connected to was injured in a workplace accident and they succumb to their injuries. You know how it feels, for that family or the people that's connected to that one person. It's just unacceptable. And I'm gonna submit this to you too. I mean, if somebody knew for a fact that when they went to work, they would pass away on that day, they probably wouldn't have went to work. Okay. It's not a thought process of a worker because the way that we got things set up. We're going to talk about why that's set up like that. But the other alarming number is, almost 500,000 people were injured badly enough to require days away from work, where the average workers' compensation premium is about $55,000. Which means a lot in a lot of different arenas. All right, I'm going to think about first and foremost uh, days away from work. If you get injured for days away from work, your life is not the same anymore. I don't care if you think I'm a bounce back or you'll be back or whatever the case is. I mean, I'm a former football player. I used to run into people every day, like and create a car accident within my body. I wake up every day with aches and pains. Okay, I wake up every day with aches and pains. I have to be intentional about taking care of my body and things like that. So people that get into an accident or an incident at work, just think about that, right? Think about the ability that, they may not be able to walk the same way again or push their child on the swing or go on a vacation or sit in the seat of an airplane seat for too long. Maybe they can't travel anymore. These are things that we got to think about, when we're trying to design systems to protect workers, because that's what I'm thinking about. I'm thinking about how do we serve humanity at the highest level, and how do we design systems that actually help the worker have success in the workplace. And when I think of success, I think about optimizing their ability to do the work and to execute it at the highest level of performance. Performance includes safety, it includes quality, it includes productivity, speed, it includes cost, okay, at the highest level of performance. So that's one of the things that I want to talk about today as we get going. Okay, so the first case study that I want to mention today, this happened in 2016. There's a news release out about this that happened. There was a fatality. So you had a worker that was working on a decommissioned large conveyor line with a torch cutter. They were installing new high-speed conveyor systems for the United Parcel Service, right? For the United Parcel Service. And they were responsible for dismantling the old conveyor system and putting in the new conveyor system. In fact, with this, it says that this was the part of the employee's regular assigned duties. Just think about that, regular assigned duties. So this is something that this person does every single day. Okay, every single day. It's a part of their regular assigned duties. All right, but this person was working and they fell 22 feet, hit the concrete floor. There weren't any witnesses right away, but for the workers that were in the vicinity that heard the thud, they saw the employee on the ground. The employee, had some trauma and was hospitalized and later died. Succumbing to this to the injuries of a 22-foot fall. All right, so just think about a 22-foot fall and the speed that somebody's traveling. Okay, if you ever been on a roller coaster, it don't take long to pick up speed when you're going vertical down, right? Gravity is pulling you down, and the weight of your body and just the speed that you pick up and the velocity. So the impact when you hit the bottom of a concrete floor is definitely one that you most likely not going to be able to get up and walk away from as everything is okay. All right, so there's a couple of things that I want to talk about with this case study that I feel is important for us to kind of unpack before we dig into how we're going to solve this problem, right? Of these changing conditions. We got regularly scheduled work. We got stuff going on. This worker is doing something that anybody else would do is they went to work and they felt like, hey, this is a task that I got to get done. Their supervisor said I got to get it done, so I got to get it done. All right. Well, 4 months, I guess after or prior to this incident, OSHA came and cited this employer for failing to provide fall protection. So we had an employer that, just was okay with workers, not having fall protection, which hence some of the willful violations that they received were targeted towards 29 CFR 1926 501 B1, which is the duty to have fall protection in construction. Okay. 2 years prior to this, and an employee suffered a serious injury in a fall. And then I'm gonna say a year after this happened, they had another employee that fell 10 feet and suffered serious injuries working from an elevated platform with no guardrail. Okay, so this is a thing, right? This is a major thing. And what I've seen a shift in the industry over the years just as a professional, that when it came to falls, we became more educated about falls. I'll say somewhere around 2015, around that time, 2014, we really started to think about fall protection. OSHA was making a good push on fall protection, and I just remember some of the stuff that was out there for fall protection. So when we look at this situation and we're saying, well, what was it about the workers' emotion? What was it about the employer's emotion around the risk that led to this situation? We got to unpack that. So we'll talk about that here in a minute. The case study that I'm gonna address here is another one. This one happened to be in the maritime industry. So you had this was in 2023, to just about 3 years ago, a couple years ago. An employee was descending a ladder into an empty vessel gas tank to perform work at the very bottom. Okay, this was something that this worker done all the time as well. Um, they had to go down the ladder at 19 and a half feet from the bottom of the tank. The employee, was on a landing. Okay, so like if you know anything about maritime regulations, they say at 20 feet, at 20, a ladder that's 20 feet has to have a ladder protective system. So they cut the ladder right before the necessary regulation for a ladder protective system. So this person went down the ladder without any protective system, and they were on this ledge. They were trying to pass down some cables and some temporary extension cords, and they fell off this landing, down to the bottom of this tank. And like I said, the distance was 30 feet from the top of the tank. So I'm gonna say it was probably somewhere around 11 feet or so, that this person fell to lower level and has suffered some head trauma and was killed due to that. Okay, so again, another situation where we have the employer who has a promise on their website where safety is their number one priority. And I always caution people about this statement because it's not that it's not a good statement, but it's saying that you're out of balance, right? You're out of balance. And so when it comes to that, being out of balance with this, deal, we got to make sure all the legs of the chair are in balance. Okay, when it comes to that. So this person's safety is our number one priority. It was their fourth fatality in 5 years, and they were initially charged with willful violations, repeat violations for 1915, Section 77C, which talks about that workers working aloft 5 feet above an unprotected side or edge has to be protected from falling, and they give you some examples in the maritime regulations, which we're going to talk about that. All right, so yes, so this is a maritime situation, and maritime is definitely when we're talking about regulations. We're going to unpack this particular deal. There also was a follow-up inspection that happened on November the 1st. Okay, November the 1st, and that was prior, 10 days prior to this actually happened. So OSHA came out and had done an inspection. All right, so let's keep moving on this. We'll keep moving on this, and I do see a couple things. I'm gonna address that. So we're good. All right. So the problem now, we got a problem frame. So we identified the problem. Now we're going to frame the problem. And this is an activity I like to really do, especially when I get on work sites or I'm trying to help a customer, create some leverage in their safe work systems. Is we got to frame problems. So the problem that I framed is, how do organizations create enough control capacity to maintain safe work when systems get challenged? All right, so and I'll mention this again. I mean, there was a situation that happened just a couple months ago in Florida, where a scaffold collapsed. Right, there was workers that were working on a temporary floor, and the scaffold collapsed, and we were just talking about it in one of my classes, just having a discussion about that particular situation. And some things, like I said, sometimes when it comes to work, normal work, because I'm gonna reference normal work, there's times where workers maybe don't have enough, or they don't have exactly what they need to get the job done. Okay. And so we have to understand the nature of people that do the work, the nature of the people that do the work. They are problem solvers by nature. Just think about the fact that somebody can come to work and do create something out of nothing, right? Or follow a design, and it's like putting together a puzzle or a Lego set, right? They just know what they're going to do. So naturally, they're thinking, okay, we're problem solvers. Just think about when you get ready to change a light bulb at home and you can't reach it. What do? You try to grab the nearest thing that can give you a boost. If it's a small box on the floor, that's enough. That's there. Cool. If it's the kitchen chair, okay, good. You got to slide the couch over, stand up. You got that. All right. Everybody's not going to go grab the self-supporting ladder out of the garage that's rated for 375 and make sure that it's good and steady, and go up and make sure everything is done. So just think about the nature of work and of workers and work being done. And this is why we got to be more vigilant, between employers, safety professionals, people that are in leadership, to try to understand how normal work is getting done. And then we have to make sure that workers have agency when they're doing what they're doing. Accountability, that's clarity before things get started, right? What do I need to actually start the job? And if I don't have everything that I need, I'm okay, and the company's okay with me saying, you know what, I don't have everything I need. I need to come and I need to get this. I don't need to try to figure that out, or my figure it out is I need to escalate, or maybe I can work around. I give some direction on how we need to, because that's a place of decision friction that exists, okay, in the workplace. So we're going to cover three things to answer this problem. I got three things that I'm going to cover. Okay, three things. So 3 points. Point number one, I'm going to address why the controls exist. Okay, and talk about the regulatory framework for fall protection. In this section, I'm going to discuss the differences between general industry, maritime construction, fall protection regulations. So we'll have some clarity on that. We'll also evaluate conditions against OSHA standards to determine compliance gaps. And so we're going to look at the case study and try to figure out, well, what conditions existed and where do the compliance regulations need to live in this particular piece. And this is the first piece. I think compliance is one of those things where, we kind of start there and then we elevate, our way of doing work because we're working on optimization, business optimization, right? We're also going to look at the risk-based factors that led to the OSHA fall protection standards. All right, the second thing that we're going to address is why systems get challenged. Okay, so what conditions create fall hazards? We got environmental conditions. They analyze those. We got place configuration. So if you know anything about a workplace, it can be configured a certain way that can challenge, a worker and them getting work done. Human performance factors, and then stability and complacency, right? Stability and complacency. I like to put those two things together because then I'm going to talk about what that means. But a stabilized system and how complacency falls into that. Okay, so we're going to make sure we look at that particular thing there. All right, so let's keep moving. All right, so let's talk about some of the historical risk-based factors that played a part in the formation of OSHA. So in 1970, you have two lawmakers and President Richard Nixon. So you have which the act is typically called the William Steiger Act, but this is the OSHA Act of 1970. It was created on December 29th, 1970, signed on that date, and it went into effect on April 28th, 1971. Okay, so you have a representative from Wisconsin who was a Republican, William Steiger, and then Senator Harrison Williams, who was a Democrat from New Jersey. They participated in signing this act. But prior to the OSHA Act of 1970, it was reported that about 14,000 people were being killed a year in the workplace, right? So this leads to this signing of the OSHA, but congressional findings, right? The congressional findings, and this is one thing I like to always hit whenever I'm talking about this. Congress saw that this was an extreme burden to interstate commerce. They felt the need to regulate interstate commerce because of this loss. Loss in production, loss in medical expenses, loss in disability compensation payments were all a hindrance to interstate commerce. Okay, and the main thing was that your human resources are being compromised. So when you think about how this goes into play, right? Congress felt like it was their purpose and policy to do this. To do this because without human resources, without a workforce, what can we do as a nation? We can't expand our infrastructure. We can't expand as a nation. We can't get into these different revolutions we had, going on. This was prior to the technical revolution. It was kind of getting, the infancy stages of that, right? And so, and so we really were looking at this as a country and saying, how do we regulate this? How do we regulate this? And when we think about this, we looked at, the BLS. The BLS was established in 1884, originally as a part of the Department of Interior. Then when the Department of Labor was created in 1913, okay, then the BLS was transferred to the Department of Labor. And historically, the Department of Labor has reported that fall slips and trips were second to transportation incidents, right? So even if you look at like the National Safety Council, workers' compensation costs, transportation incidents are at the top of number one, okay? At the top of number one. So that's the deal with that. And we look at these high risk industries such as construction, we look at maintenance, building grounds, shipyards. These are all high risk industries where the OSHA requires the employer to have a duty to provide fall protection to their employees. Okay, so that was what OSHA was. So with the Department of Labor, we're going to unpack the 1910 Code of Federal Regulations around the duty to have fall protection. We're going to look at 1926, which is construction, 1917, 18, or 15, 17, 18 for maritime, and then agriculture was part 1928. Okay. So looking at these components of each Code of Federal Regulations, we have in 1910 the subpart D is the walking working surfaces subpart in part 1910, which is for general industry. And with them, with general industry, it goes in talking about the protection from fall hazards as it relates to unprotected sides and edges. Then it goes into looking at the just the aspects of how do we, what is the standard, protect workers or set up to protect workers. Well, it talks about guardrail systems. It talks about safety net systems. It talks about fall arrest systems, such as travel restraint, arrest, positioning systems. These are all there. It also talks about areas where workers could see unprotected sides or edges, such as poles, dock boards, runways, working over dangerous equipment, any openings, which are gaps in walls or partition in the walking working surfaces, and repair service pits. So like when you go to get your oil changed at Valvoline, if you go there, they got to repair a service pit. If it's greater than 10 feet, then it's got to have fall protection. So they keep them less than that, so they don't have to see. That's why it's wide open when you see that. But you got those. You also got stairways, ladders, and low slope roofs. And so these are all parts of general industry, and we're going to talk a little bit about that when we start talking about controls. For maritime, the maritime fall protection regulations are going to be found in 1915, 29 CFR 1915, 1917, 1918. Excuse the misprint there, right? 29 CFR 1915, 17, 18. So 29, 1915, subpart E, it talks about scaffold, ladders, and other walking or working surfaces. And particularly when it comes to that, section 73 in paragraph D, it mentions the employees exposed to unguarded edges on decks, platforms, and flats, okay, or any similar surfaces. They have to be protected, if it's more than 5 feet. Well, general industry was 4 feet. Maritime says it's more than 5 feet. We got to protect them from falling. Okay, and then obviously 77, section 77C, which deals with the working surfaces, and it says workers working aloft in elevations 5 feet or more above a lower level, should be protected from falling. And it gives some options, safety belts, lifelines, those types of things. They say it should also be afforded safe footing on that particular deal. So we looking at that case study. I mean, that worker, was definitely 5 feet above a lower level and was unprotected. All right, 1917 deals with terminal facilities. So the guarding of edges, platforms, the skids, fixed ladders. So remember, I mentioned the fixed ladder situation in that particular deal, and in this standard, 1917, section 118, paragraph E, subparagraph 1, fixed ladders more than 20 feet in height shall be provided with the cage, wheel, or ladder safety device. So that ladder had a break in elevation at 19 and a half feet. So that's how I say they kind of got around the regulation with that as it relates to that. If you ever look up any pictures with, just the shipyard and, the cleaning of fuel tanks and things like that, I mean, these are normally ladders that they have to attach to that tank in order to go down in them and do certain things or whatever the case is. You also have in part 1918, it talks about specialized terminals in subpart D. So wherever you have any stowed cargo or temporary landing surfaces, things like that, if you got an edge, anybody is at the edge of a hatch or stowed cargo, anything like that, they have to be protected from falls. Okay, if they're near the edge of of water, they have to be protected from stowed falls. So from falls. So this is the maritime regulation. Okay, maritime, and now we're going to jump to um, construction. Right, 29 CFR Part 1926, construction. And so construction is pretty unique in the simple fact that, as you can see, there's a lot of subparts here that deal with, that have their own fall protection standards. The one that we're most familiar with is subpart M, which, subpart M deals with unprotected sides and edges, 6 feet or more above a lower level. Okay, and it gives you plenty of options or areas in the workplace where, falls would take place according to this subpart M, where it would be subject to this subpart, such as hoist areas, leading edges, form work, reinforcing steel, ramps, runways, excavations, dangerous equipment, overhand bricklaying, roofing on low slope or steep roofs, precast concrete erection, so on and so forth, right? Residential construction. That's subpart M. But subpart M has a lot of exceptions in it. So one of the exceptions they mention is it does not cover fall protection in subpart L, which is for scaffolds. Okay, so subpart L has a different trigger height. Their trigger height is at 10 feet. Okay, 10 feet or more above a lower level, have to be protected from falling. And subpart M mentions guardrail system, safety nets, fall protection. Subpart L mentions the same thing. Okay, it also excludes subpart R. Subpart R, steel erection. Steel erection has fall protection, right? Fall protection requirements, 15 feet or more above a lower level. Okay, for just general workers working in steel erection activities. For connectors, those are the workers that are actually connecting the steel members together. 2 stories, 2 stories or more, up to 30 feet. Okay, whichever comes first for connectors. And then controlled access zone, same thing, 15 to 30 feet for controlled access zone. Anytime you hear the word zone in OSHA, it's an area where only authorized personnel can be in, and the potential when it comes to fall protection, there's potential that there's no conventional fall protection method in a zone. All right, so just be aware when you hear the word zone. And then I'd also mention subpart X. It doesn't talk about stairways and ladders. With stairways and ladders, they have their own fall protection method when it comes to stairways. If you got, 4 or more risers, and you need to have stair rails and handrails. Okay, for the stair rail is for the fall protection, the handrail is for just a handhold. And then, ladders, we talk about fixed ladders in subpart X in construction deals with ladders that are anything over 24 feet. That's a fixed ladder, has to have, a cage, a well, or a ladder safety device. Okay, and then subpart CC, cranes. Okay, cranes, we're talking about 6 feet or more above a lower level when you have non-disassembly or assembly work, 15 or more feet above a lower level on horizontal lattice boom cranes. Tower cranes, same thing when you're erecting, climbing, dismantling work on tower cranes, 15 or more feet above a lower level. They mentioned guardrails, grab rails, handholds. They mentioned personal fall arrest system. The anchorage points are not going to be the same as what subpart M is. It's going to be subject to ISO 11660, which has part 1, 2, and 3. Part 1 deals with just the general requirements. Part 2 of ISO 11660 deals with mobile cranes, and part 3 of 11660 deals with tower cranes. All right, so, and then it says anchorage to a substantial part of the crane equipment. So there's some different verbiage there about that as well. So let's evaluate the conditions. All right, so we're at this place now Where now we're going to look at the compliance gaps and the conditions and the compliance gaps that create fall hazards. So we got a condition where an employee fell 13 and a half feet on a catwalk on a mezzanine grading. This case study number one is subject to construction standards. Okay, so this happened a month after the actual death, but they got cited for it on the same deal because if you look at Section 501 in the 1926 subpart M, paragraph A, subparagraph 2 talks about walking working surfaces have to have the employers have to make sure the walking working surfaces have the structural integrity to hold, an employee. Okay, so we got to start right there. And then in that situation, we also have an employee that was exposed to fall hazards while engaged in construction demolition. They were 6 feet or more above a lower level. They fell 22 feet. Okay, so that's a duty to have fall protection standard. Okay, so like they have a duty. A worker has a right to have fall protection. They should not be in a position in the workplace where they do not have fall protection. Okay, they have the right and the duty that is an employee right. That's why they call it a duty. In the second case study, we had 8 feet to 20 feet fall hazard. They didn't have a guardrail system on the platform. So remember, 5 feet or more above or working aloft is what they say in the Maritime standard. You got to have protection for the workers, okay, from falls. So looking at this for shipyard employment, 77C, section 77C of part 1915 deals with that. And then we have the compliance regulation for illumination because it was poor lighting in the area that can contribute to some environmental conditions that we need to, and also some work configuration conditions that we need to be aware of because the lighting was poor, okay, in that area. As they went down into the tank, they needed to have sufficient lighting. So every time we finish a module, we're going to have a nice little transformational question that's going to put something on your mind. And I want to put this on your mind as we move to the next module. Are OSHA standards designed to eliminate risk or manage it to an acceptable level? Okay. Are the OSHA standards designed to eliminate risk or manage it to an acceptable level? That's the question that we got to ask ourselves. Because we can be in compliance with OSHA regulations, and this is something that we got to make sure that we understand. It doesn't necessarily mean it's the absolute optimal situation for the worker to have the most success that they can have. Because we serving humanity. We trying to make sure we give people the absolute opportunity to be the best that they can be. Why? Because they're getting up every day, they putting on their work clothes. You know how it go. You look at your family, you know what goals you have, you know what you want to do, and you going out the house, not because it's just an instinct, okay, but because you got something that you're working, striving towards. Right? We should honor that. That's called honor, right? We got to honor that in the workplace. All right. So we got to make sure we get that piece there. I take that very serious when it comes to me. And when I think about my opportunity to do something for somebody, I'm thinking about every soul that's connected to that person. That reason why when they look themselves in the mirror, let's go. They may not feel like it, they may not want to do it, but they getting out and they getting after it. They deserve to be in the best situation that they can be in so they can optimize the work that they can do. All right. So that's my little spiel on that. Now, module two, conditions that destabilize work. So we're talking about the challenges that come into play. All right, and there was a couple challenges that we looked at in this particular deal. So we got compliance out the way. Now we want to look at environmental conditions. We want to look at maybe workplace configurations, possible human performance factors, right? Human performance factors, and assess the system stability and complacency risk. Okay, so we're going to look at all these different things in this particular deal. Now, when it comes to environmental conditions, I'm going to just tell a quick hitter story. Okay, remember there was a worker working at elevation, and they were tied off. They were doing everything right. But one thing we didn't account for the fact that there was water on the walking working surface that was exposed to sun, and algae grew right there. And when the workers stepped down on the algae, they dislocated their knee and they was out of work for about 45 days, a lost time incident, okay? So we got to think about these environmental conditions and how they create slick surfaces, how they create obstacles and clutter, how they could be, plant growth or organic degradation. If you got a wood surface, wood is a living thing. Well, obviously was before you cut the tree down, right? But in the sense of the way it's made, okay, it's got pores, it's got a binder called lignin, okay, in the wood, and over time that wood is subject to the different things in the environment. If you got a really corrosive environment, that wood's going to break down, okay, on the surface. And if you're talking about these falls to the same level, I mean, it could be some situation that things just are not in good condition. Maybe you don't have sufficient lighting. Okay, natural light. You got to provide temporary lighting. Temporary lighting, anytime you have temporary lighting, you got shadows and people that, the depth perception is not the same as it is when you're out in natural light. Okay. And the surface irregularity. So just think about these conditions here. Workplace configurations. So when I think of workplace configurations, I think about another situation, where a worker was involved in a near miss. They actually got fired because they, and it shouldn't have went like that. But either way it goes, they stepped over, an area on the scaffold that wasn't necessarily, blocked in, and they weren't tied off. They didn't know because there was some ambiguity in the signage of on the scaffold, right? So we got signs and signals, and I see green, but you see purple, right? You don't know that until you ask me what I see. I see green, but you see purple, and I say, well, hey, I see green. No, you're supposed to be seeing purple. Well, you don't know. You don't know. That's my perception, right, of things. So we talk about signs and signals. It's not as easy as just like, hey, read the sign. You know, what does the worker perceive? The complexity of the task plus the operational pressure. I just talked about that earlier. Okay, workers are always under the gun to get stuff done. They got to make sure they get stuff done in a timely fashion. And then you got temporary, elevated or non-elevated walking worker surfaces. Anytime you construct something temporary, it could have some flaws. That's an engineering risk of putting things together, that engineering things can fail. And then elevated, non-elevated walking work surface that challenge task ergonomics. So maybe you got to step over something or dip underneath something or be in a crouching position, okay, during the task. Access and egress for upper levels. How we get to an upper level? Sometimes we got to use a ladder, whatever the case is. I mean, and a lot of times that's like yeah, just grab the ladder. But some places say ladders last, right? And we kind of fall into play with that. We got to think about that particular deal, workplace configuration. So human performance factors, these conditions are very unique, where we talk about, some of the physiological and scientific variables that come into play with human performance. Okay, this is a deal where we think about understanding the factors that's crucial for designing error tolerant environments. Okay, and human performance is all about optimizing the overall productivity, improving workplace safety, continuous improving, and everything that comes with that. So when you got professional discipline, when you got like engineers and people that are, that have licenses and certifications and things, we got to think about, when it comes to their, competence, and the safeguards that they put in place. How do we adhere to that or analyze that? When it comes to worker expertise is basically a high level of skill. It's a high level of skill. How much expertise does a worker have in what they do? Because expertise absolutely affects their judgment in a particular field. It also affects their ability to, see or experience things hands on, and they rely a lot on their training and their experience and their studies. Okay, and then you got these physiological conditions that people have: bad backs. They might have chronic diseases. Could be high blood pressure, diabetes, foot problems. Things that cause people to have all of a sudden 1 minute they're fine, the next minute they got a low sugar, and then now the equilibrium is off. Okay, and we got to think about these things. I used to have a lot of workers that work for a company I work for that did take insulin other types of medication on a daily basis, because they had to regulate certain things in their body. And if for some reason they were exposed to heat stress, or maybe they did too much the night before, or they've been eating fast food because they've been on the road and everything is kind of out of whack, you got a situation where you got these physiological conditions that you got to take into play. Okay, maybe they got an injury a long time ago when they broke their hip, and now they're having a situation with that. Okay, all right. So mental health is another piece that we got to be aware of. And I like talking about this because we're talking about the emotional and the social well-being of people, okay, as it relates to this. All right, the emotional and social well-being. And then we got the motivation. The motivation. Why do people do what they do? Why do people do what they do? And Maslow's hierarchy of needs will tell you, that people they have a physiological need where they got to survive. Sometimes they have safety needs. Sometimes they have esteem. Sometimes they have needs where they have self-actualization, where they want to get all the way to the top. You can assess all these things when it comes to that. Okay. And then we're talking about stable systems and complacency. So one thing that you should be aware of is that a naturally occurring phenomena of being stable, or a system stabilizing, is that complacency is a natural occurring phenomena of that. Okay, things become complacent. It's not because the worker is just, hey, I'm laying back, I'm cool. It's everything becomes complacent. Our tolerance for the risk and our emotion around the risk, our perception around the risk comes down. It's not as heightened as it was before because nothing's happened. Nothing's happened. You go 10, 12 years without nothing happening, all of a sudden you have a fatality. Okay, because things were stabilized. But the problem is that maybe you weren't addressing some of the places where you were having challenges, some of the changes in the workplace, because they weren't brought to your attention, by the workforce, right? The worker is the solution to the problem that we have in the workplace. We got to talk to the workers. The workers know exactly what they need, and they know how to and they know exactly what they need to be successful. So we have to be aware of that. But we got to think about perception. Perception for a human is reality, and what you perceive is not what I perceive. I said that before, and we got to understand that if perception is one of those things, we got to check the people's competency. We got to make sure that they're competent in what they're doing. We also have to look at systems. Where are our safeguards low in our systems? Are we doing enough to really look at and I'm talking stable systems. I'm talking nothing's happened in the past 10 years, and we've been doing this task 10,000 times. Where are the safeguards low? That's the question we should be asking, right? And then you also think about like effect heuristics, right? Effect heuristics, these mental shortcuts that people make with their current emotions. It pretty much guides them subconsciously and influences their decisions about risk and reward. And risk is attractive, for those that ride motorcycles and rock climb and bungee jump and do turn. I played football at college, Tennessee State University. And what I loved about football the most was I got to run into somebody full speed. That's risk. That's risk. Why do I love that? Well, it's attractive, right? Risk is attractive. So yeah, when the worker is like, hey, you know what? I think I can make it. It's because it's something stands that the hair stand up on the back of their neck, and they like, look, I think I can get through. And when they get through, nobody says nothing about it. So we don't know that this situation has been going on for the past 5 years. They got to step over a 4-foot gap to get to their working service. But now today somebody just fell into a very dangerous toxic chemical and passed away. Well, we didn't know that was because we're not taking the time to learn. Okay, learning is vital when it comes to our organizations. And where do we learn? Well, we learn from the workers. Okay, we learn from the workers. We talk about situations like, hey, what's our most ridiculous safety policy that we have right now? You can ask questions like that. What's the most ridiculous thing that we do for safety? Okay. Happiness index. Okay. How do you feel today? Okay. All right. What about this work environment do you dislike the most? Okay, these are things that we can ask questions about in our meetings, get people to talking to us. Now, going back to our case studies, okay? Case studies. So in case study number one, we got a condition. Employee was working on a decommissioned conveyor line with a torch cutter. They were moving small metal conveyors running transverse large to a large conveyor. All right. Conditions that exist. Okay. Environmental conditions. We have obstacles, clutter. We got workplace configuration where we got elevated walking working surface, and we got human performance factors. Okay. Human performance factors. What was the employee's perception of that risk? What was the employer's perception of that risk? Okay, we got to ask these questions. Then conditions. Employees are exposed to fall struck by hazards while engaged in construction. So one thing that goes with fall protection all the time is falling object protection. Okay, and when we look at that, we look at human performance as well on that, right? We look at human performance. Now, the other thing, and workplace configuration. Now, the other thing that we got in case study two is descending a ladder into an empty marine vessel gas tank, okay, to perform work at the bottom of the tank. We got workplace configuration conditions. We have human performance. Again, what was the employees and the employer's perception of that risk? How many times have they done that? Okay, and those are things that we have to look at and ask ourselves those questions. Okay, transformational question time. Transformational question time. This is where we get to the meat and potatoes. If hazards are dynamic, okay, if hazards are dynamic, how do we choose controls that actually work? How do we choose? So this question, Randy, is geared towards the reality that if a worker knew that they were going to fall, they probably wouldn't fall. Okay, I'm gonna just go on and say that. If a worker knew they were going to fall, they wouldn't fall. They would not fall. Okay, they would not fall. And in fact, the thought of a potential fall that could be deadly might have been enough to be like, you know what? Maybe there's a change I need to make. Maybe I need to go talk to somebody about something, right? And so basically, this question kind of leads me in the direction of saying, well, how much agency do these workers have? That comes from the employer, okay? That comes from the organizational culture, comes from the design of the system, okay? How much agency do these workers have? That's a person's physiological or psychological capacity, right, to make independent choices. And we have to rely on workers to do that. They're humans, right? We got to rely on them to make independent choices, but we got to open the door. We got to open the door for it. See, what happens is when you respond a certain way one time, when somebody brings you something, then it sets the tone for everything else. All right, so we got to make sure we're aware of that. Now, getting to our last module, we're going to talk about how capacity is built. Okay, when I think about capacity, I'm thinking about the readiness to start a job, the assurance that controls are in place, and when it fails, it fails elegantly enough that there's the least amount of impact on operations, production, safety, and reliability when it fails. So that's a hard pill to swallow for organizations. I always, it's hard for people to think about that. We always think about we're going to prevent the absence. Safety is the absence of things happening. When really, it's the presence of control, and it's the presence of enough control capacity. Okay, so that when something fails, it fails elegantly. Okay, elegantly. And this is where we got to start looking at this. Think about the car industry, right? Think about the car industry. You got cars now that when you get into an accident, it's going to put you in a certain spot, okay, so that you'll be right in position for where the airbags come out, and therefore you won't pass away if you flip over in the car. Okay, that's saying that we're going to have an accident. That's what that's saying. All right, we're going to have an accident. Or you have the sensors on the front of the car that brake for you, okay, because you done got too close. Or you can set them back 2-3 car lengths if you set the cruise control if you're traveling across the country. All right, we're saying that somebody gonna fall asleep at the wheel, somebody gonna be texting and driving. Okay, what about the lane assist? Scares the mess out. Okay, Somebody gonna be texting, somebody gonna be talking on the phone, somebody gonna be distracted, okay, in the car. We're saying that. We're saying that. There's gonna be some error. So we gotta look at the fact that we gotta evaluate the opportunities for hazard elimination, analyze passive protection methods, assess active protection systems and limitations, and compare and justify control selection. So I like to show this right here because this kind of shows you, like, when it comes to fall protection, this is what we're trying to do. We're at get to the top. Get to the top. Can we eliminate the hazard? Can we remove it? Okay. If we can't remove it, or can we put a physical barrier in place, which is a passive control method. Okay. Maybe we got to include a restraint. Okay, a restraint, restricting workers from the fall hazard. Okay? And then when we get to the arrest situation, and maybe some of the admin controls, this is where we got to start having the conversation. When the worker falls, if we arrest the fall, do we got enough clearance? Are we prepared for a lost time injury? Because I would say in my experience, anytime we had a fall arrest, days away from work. Okay, days away from work. And are we okay with that? Is that an acceptable risk for us as an organization? Risk has a lot of different facets. I used to sell insurance, so it has a lot of different facets. Is that an acceptable risk for us? Can we tolerate a lost time incident? Maybe we're a small organization. We might not be able to tolerate that. Okay, so we got to we got to get to a higher level on the hierarchy of controls. So this is pretty cool. When it comes to hazard elimination, can we do the work on the ground level? Is that possible? Can we use robotics? Okay, and let the humans operate the robotics? Okay, can we remove any irregularities from the surface? Irregularities. Access egress ramps instead of stairs and ladders. That don't have unprotected sides and edges. Okay, and slips and trips and removing those hazards. Okay, and then performing work indoors instead of outdoors if you got environmental conditions like rain or snow or ice or anything like that. Okay, can we do that? I mean, I had a worker slip and fall on ice before at elevation and was in a fall arrest. So, I'm very sensitive to that when it comes to that. So here are some passive controls. Passive controls, and this is just a list. One I'm gonna talk about every one on this list, but the first one I'm gonna talk about is engineered cocoons. So engineered cocoons, they're high-tech, temporary, modular structural shielding systems. So if you're doing any type of multi-story building construction, you can put a whole entire cocoon. I'm not saying that this is it, but if you look up engineered cocoons, this is something that from an engineering standpoint, you can design this around the building, and workers can work freely without any restrictions when it comes to that. But we're going to unpack guardrail systems, safety nets, stair rails, handrails, warning lines, barricades, okay, and all that stuff there. So guardrail systems, okay, these are passive controls. They consist of a top rail, a mid rail, and then you have to have some type of falling object protection if you got a falling object hazard. And I would say 95% of the time you're going to have a falling object hazard below, so you have to have some type of toe board or something like that. Guardrails can be at least a 1/4 inch in diameter and thickness. If they're wire rope guardrails, you got to have them flagged every 6 feet. The top rail of the guardrail system, according to subpart M, is 42 inches plus or minus 3. Same guardrails in general industry as well. 42 inches plus or minus 3. They got to be able to withstand 200 pounds of force in an outward downward direction. The mid rail's got to be in between at 21 inches, 150 pounds of force outward downward direction. Toe board's 3.5 inches. Okay, for the cranes adhere to ISO 11660 for their requirements for guardrails. Okay, so that's something there. For safety nets. Safety nets is a passive control. So we're trying to put a barrier between the worker and the fall hazard, which the hazard on the fall is the lower level, okay, or the same level, right? So passive control is safety net. We're going to stop the worker from hitting the ground by providing a safety net barrier, there where workers can still work freely without being attached to something. And if they do fall, they'll fall into the safety net. Now, they got to be drop tested with a 400-pound sandbag. They got to be frequently inspected by a qualified person, installed under the supervision of a qualified person, and frequently inspected by a competent person, installed under the supervision of a qualified person, and then they got to be capable of withstanding 17,500 pounds of foot-pounds of impact resistance. Okay. The edge ropes have to have a minimum breaking strength of 5,000 pounds, and they can be installed no more than 25 feet below the work surface. Okay, no more than 8 feet from the horizontal. Okay, that's the safety net systems. So stair rails and handrails, and I kind of with this one, I kind of put construction next to general industry because there's some differences there. Okay, I'll start on the left side with construction. Construction says, and general industry both have 4 or more risers of 30 inches with unprotected sides or edges. Then you got to have handrail, stair rail. Okay, so that's a component of fall protection. The stair rail system is for construction. Handrails installed not less than 37 inches, okay? And stair rails have to be installed not less than 36 inches. They got to be capable of withstanding 200 pounds of force, which is the same in general industry. And like general industry, if you have a landing on a stairway, it's got to have a guardrail system to protect the workers from falls, unprotected sides and edges. Of course, general industry, the handrail has to be not less than 30 inches, but not more than 38 inches. If your stair rail was installed before 2017, it could be not less than 30 inches, but if it's installed after 2017, not less than 42 inches on the stair rail. So that's the fall protection component of the stairway. Stair rails can serve as the handrails if they're not less than 36 inches and not more than 38 inches. Same thing with the construction standard. You can have the stair rail and the handrail be the same component as long as it's installed at the correct height. All right, so it's there for that. And then you have these warning lines. So a warning line is simply we're going to designate an area different from a zone. We're going to designate an area where workers are protected from a fall hazard, and they can work freely without being connected. This is why we call it passive. Okay, so if it's infrequent work and particularly you'll see these on roofs, but if it's infrequent work, you could be as little as 6 feet away from the edge on the warning line. If it's frequent work, then it's got to be 15 feet, or for other work, 15 feet from the edge. Okay, it's got to be flagged every 6 feet. It can be made out of a wire rope or a chain. Okay, and at the same time, it's got to be clearly visible from 25 feet away. So it's got to be, something that can be seen from a distance. All right. It's got to have a breaking strength of 200 pounds in general industry and a breaking strength of 500 pounds in construction. And because of the way that it's put together, you'll see some sag in it, but the sag can be no less than 34 inches from the ground, okay, and no more than 39 inches on the sag of a warning line. All right, then you got your skylights and your hole covers. So when it comes to skylights, hole covers, speaking about skylights, they got to be fastened on, covering the skylight as a guard in case of a worker, stumbles and happens to fall on the skylight. Workers can fall through skylights. Okay, that's it's not something that's designed impact to withstand the force of somebody falling on it. But for holes have to be color coded. They got to be labeled hole or cover, and they have to be fastened to the ground to cover a hole, except for your cast iron manhole or steel grates that's used on the streets and roadways. All right, so they don't have to be demarcated with a hole or cover, but they have to be able to support 2 times the maximum load. So that's with your skylight covers and for your hole covers. All right, good. Got that under control. Now we're going to go to active controls. Now with these active controls, as you can see in the photo here, you got a worker that's connected to an anchorage. So now we're going to actively connect the worker to the fall protection. an approved anchorage, based on OSHA's regulations, right? This is an order picker that you might see in a warehouse or something like that, where workers quote unquote tied off, right? Tied off. Um, but we're going to talk about the ABCs of fall protection briefly. I'm going to give you just some brief overview on that, and maybe some points that you can go back and look and read on your own. We're going to talk about restraint, positioning, fall arrest, and then I like to include rescue in there too, because rescue is a component of active controls as it relates to that. And so ANSI ASSP Z359 is the fall protection code. Okay, they have the fall protection program. They got fall restraint, fall protection equipment. They discuss fall protection systems, and they got 17 sections that deal with this. So I'm gonna reference a couple of these ANSI Z359 standards, because these are some of the performance standards and testing standards that you'll see out in the field when it comes to fall protection or active fall protection and workers that are wearing equipment and connecting to an anchor point, or an anchorage. All right, but let's talk about the anchorage, the A of the ABCs of fall protection. The anchorage has to meet 5,000 pounds per employee attached. It has to be designed, installed under the supervision of a qualified person with a safety factor of 2. Okay, so that's the beam. You see the beam, boom. Now we got an anchorage connector. That's the clamp that you see right there, connects to the anchor. You can also use that beam strap that worker has as an anchorage connector. Okay, anchorage connectors have to be drop forged, pressed or formed steel. They got to be smooth, corrosion resistant. Okay, any D-rings have to be, and snap hooks have to have a minimum tensile strength of 5,000 pounds and minimum tensile load without cracking of 3,000 pounds. All right, but when we talk about anchorages, the anchorage is a very important component of fall protection, because if you don't have a good anchorage, then you're not going to protect the worker in the event of a load on that fall protection system. Horizontal and vertical lifelines, that's what this is. So to the left, you got your horizontal lifelines, and to the right, you got your vertical lifelines. So hence the name horizontal, vertical. Okay, these are anchorage connectors. So they connect to an anchorage as well. The horizontal and vertical lifelines have to have at least a 5,000 pound per employee minimum breaking strength. Okay, they also have to be protected against cuts or any rough edges. Designed and installed under the supervision of a qualified person. That is a common theme in the fall protection regulation. Anytime you have the active systems and passive systems, they got to be designed, installed under the supervision of a qualified person. Now, the B portion of the ABCs, body supports. Okay, body support. You got the body harness. Now, ANSI Z359, Section 11 in 2021 has different classes of body harnesses, and the classes depend on where the D-ring is located. Okay, on the body harness. Okay, and where it's tested, what it's tested for. So if you got a Class A harness, that's your typical fall arrest harness. Your D-ring gonna be in the back. If you got a Class D, it's because you're using the harness for controlled descent. It's a sternal D-ring. If you got a Class E, you're going to have a shoulder D-rings because you're looking for retrieval. Somebody's going to be able to retrieve you, pull you out of a situation. Class L is a ladder climbing safety system harness where you got the waist and the hip D-rings. And Class P has the hip D-rings for position. Okay, you could also buy a multi-purpose harness that has multiple D-rings on it, like the one shows right here. It's got the hip and the one in the back. Okay, and just be aware with ANSI 130 to 310. When you go to the manufacturer specifications, they'll say they qualified up to 420 in the manufacturer specifications. So Guardian, Werner, 3M, all those things, different Fall Tech, up to 420. And they mention that on the rest of their components as well, because the OSHA in standard talks about that if an employer needs to have a worker that has a combined body weight and tools and equipment over the 310, they got to be able to demonstrate that the fall protection system is designed for the additional weight. And if they can, then they'll fall in compliance with the regulation. That's what it talks about there. So you can look that up if you want to look that up. Now let's talk about connectors. Connectors. This is the C of the ABCs. Connectors. Connectors. We're talking about SRLs. So with SRLs, you have three different types of SRLs now with the newest standard that came out 2021 with that ANSI Z359 Section 14. Okay, Section 14. You got an SRLP, which is shown here for personal, fall arrest that's worn actually on the worker. You got your SRLR, which is for rescue. So if you got a tripod and something attached to it, that's where you go say SRLR. And then you got your normal SRL, which is designed for the overhead, component, which we saw in the first picture with the anchorage. You attach it to something overhead, and those are typically 20 feet or more on the line for those. Okay. They're also broken down into class 1 and class 2, and this is where you can actually tie off either above head or below the dorsal ring, the D ring in the back. The class 1 is designed for just an overhead anchor. Class 2 is designed for an anchor above overhead and below the dorsal ring, 5 feet below. Okay, so you should be aware of that. And then they limit the free fall distance to 2 feet. They also have a maximum resting distance of 42 inches. Okay, maximum resting distance of 42 inches. So so they stop you pretty fast to make sure that you have some you don't exceed the free fall distance that OSHA says that you should not exceed of 6 feet. The SRLs have pretty much replaced these lanyards, but I wanted to put them in here just because I know they're still on the market. People still buy them for different applications. So you can buy them single leg or twin leg. They can be energy absorbing, meaning they're going to give you some deceleration at the bottom of a fall. They're going to limit your free fall distance to 6 feet, and all those things like that. So just be aware this is a connector too. And then you have your positioning restraint connectors. These are to keep the worker in a work position or to restrain the worker from getting too close to a fall hazard. So you'll typically see these will be connected. Have two snap hooks that'll connect to an anchorage. And that way the worker can be in a position and just work without any interferences. All right. And then you got your ladder safety system. Your ladder safety systems are connectors. They connect to an anchorage on a fixed ladder. And the deadline for the fixed ladders, I believe, was 2036 for those with the ladder safety systems. But you'll see this on ladder safety system where it connects to the hip, and the worker can go up and down the ladder. And if for some reason they lose their footing or they lose their hand placement, it'll keep them right there on the ladder. I think the purpose of changing out the cages because it was becoming increasingly difficult for rescuers to rescue people that were caught in the cages. Okay, so just thinking about that, I've been hearing about that change. It's been for a little while, and I think it keeps getting pushed back. But either way it goes, let's move on to restraint. So restraint in this picture, like it shows, we're going to restrain the worker from getting close to the fall hazard. We're only going to allow the worker to get so close to the fall hazard. This restraint system has to be connected to an anchorage. Okay, that's 2 times the impact load, or 3,000 pounds. It's going to limit the travel distance. All right, you'll use restraint in aerial lifts. In subpart V in construction, they have a fall protection deal too, but it's mainly talks about with aerial lifts that you can use restraint or fall arrest in subpart V, which is the electric transmission distribution power generation subpart in construction. All right, so aerial lifts and is there for that. Okay, for restraint. All right, and then
Aaron?
yes,
Aaron, we got about 10 minutes before we're at time, so
okay.
I want to leave at least a couple of minutes for questions. So keep going, but I just want to give you a heads up.
Yeah, I'll move through to my conclusion. I'm almost there now. So active positioning systems, we got fall arrest. I've kind of talked through that already. And then rescue, right? Rescue, we got to make sure we have enough. We have to provide prompt rescue according to the OSHA standard. And then the last one is the admin controls. And these are things that because conventional plans are infeasible, or maybe it's impossible to comply with the standard, then you can use admin controls. Training is an admin control, certifications, qualified persons, competent persons, and the like. All right, so let's talk about the control selection real quick here. We had low controls where the worker was working above, and also the employer did not instruct the employee in the recognition and the avoidance of unsafe conditions. So that was the control that was low. So we got passive systems we can input, as well as active systems, as well as some admin controls like training, competent person inspections, qualified person designs, those types of things. With the second case study, descending a ladder, we got that as well. And we can use elimination, maybe some robotics, possible passive system, a guardrail around that landing, and also some admin controls and training. So key takeaways with this. Key takeaways, I like to formulate questions. Why did OSHA create the standards? Okay, we touched on that. Why do systems still fail even when there are standards? Okay. And then how do we engineer enough control to withstand disruption? The final learning arc that we have for this class, and I'm done. Safe work or normal work is not the absence of risk. It is the presence of enough control capacity. When it fails, does it have enough elegance to fail with the least amount of impact as possible on operations, production, safety, and reliability? Chew on that. All right.
Well done, sir. So before we get to the questions, I want to share the survey link that if you can take a few minutes and take a picture of this QR code with your camera, it'll help us create more webinars and what you're interested in, etc. So I'm going to leave that up here, and I'm going to start to go to the questions and just fire them off and we go. So, all right. Hang on here. One of the questions that came through, Aaron, was from the case study. One of the case studies, was it a willful violation that we saw? Yes.
So the first case study had several willful violations related to 1926 501B, duty to have fall protection, and several repeated violations. And then I believe the second case study, it was initially a willful violation, and it reduced down to to a serious violation.
Okay. Let me go to more. I'm going to stop sharing. If everyone has this picture, if you can take it real quick, or answer what's up on the screen, the poll. Let me go into the questions. All right. So from the beginning, from the top, what are the general harness requirements for fall protection for aerial workers in telecommunications? Pretty specific, but.
So can you repeat that one more time?
Yep. What are the general harness requirements for fall protection for aerial workers in telecommunications?
In telecommunications, aerial workers. So harness requirements, you're gonna find those in ANSI. Is that the question for harness requirements,
Yes.
Sean?
Yep.
You're gonna find those in ANSI Z359 section 11. ANSI Z359 section 11. That's where all the harness requirements are for that.
All right. Next question. What are the most common injuries related to falls?
Yeah, so I would say anything that could create a sprain, strain, break, also head trauma. Those are some of the common injuries, all physical injuries, musculoskeletal injuries.
All right. I think this question might have been answered within the chat, but for everybody else, why are there different fall protection requirements for various lift devices, i.e. aerial lifts, scissor lifts? Is it different for general industry?
No. So if you look at the regulations, they typically don't really mention anything about the scissor lifts. If you go to OSHA.gov, they have a nice overview on scissor lifts. They mentioned the guardrail system in that overview as it relates to scissor lifts. as the fall protection. I think that it's a general work practice to engage in a restraint or personal fall arrest system while working in the aerial lift and a scissor lift. But a scissor lift, by definition, it meets the definition of a scaffold, but it is not represented. And general industry does not have a standard for scaffolding. It references the construction standard for scaffolding, subpart L. So when you go to scaffolding general industry, it's going to take you to 1926 subpart L regulations for scaffolding. And 453 talks about aerial lifts, but it doesn't mention anything about scissor lifts. But it is a temporary elevated work platform, and it should be seen as one, that the worker is protected by the guardrail system. And if for some reason they need to, reach outside of the guardrail system, then they probably need to have a restraint system on.
Okay. Next one. Why do companies insist on employees wearing a restraint lanyard or any lanyard while working in a scissor lift at 9 or 12 feet? Why isn't height of the worker, height working at, and lanyard factored in?
Yeah, it shouldn't be based on height at all. I think that it should just be based on what's the nature of the work. Is the worker working in a safe ergonomic position, or are they having to reach outside of the confines of the scissor lift? It really, to me, height doesn't really matter because we got a guardrail system in place. And a scissor lift is one of those lifts where you put in, it's a stationary lift. You don't move a scissor lift while you're in elevation. You bring it down and then you move it to your next location. Where an aerial lift is a little different, where you might have a worker that, and will operate the lift with the boom extended to a degree. So it shouldn't really be based on height. It should be based on the nature of work.
All right. Here's one that's a little different, and I think it goes to philosophy, but it says, for both ladder and bucket trucks, how can we ensure that workers are wearing their harness properly when working alone and not taking shortcuts?
Okay, good. So job briefing. And this is the thing. You're gonna have to, so this is an organizational culture thing too. So when you think about, okay, what do workers do when nobody's watching? These are the questions that you got to get answered, and you're not going to get them answered by going out and looking, because when you go out and observe, they're going to do everything right. You got to get surveys. You got to figure out. You got to get assessments to see where people's minds are and head is. Unless you do something like put a camera inside that deal to watch them all day long. But you got to be able to create that synergy in the culture.
All right. In regards to loading docks, is that considered unguarded railing, and how should it be approached?
Yeah, so loading docks is considered unguarded, and if it's 4 feet or more above the lower level, it's like in subpart D as it relates to walking working surfaces, it should be protected. I used to drive trucks for a little bit, and I know there's a lot of them that don't have, you literally can jump down off of that loading dock if the door is open. When you open that door, your worker is 100% exposed to a fall hazard. So they should have some type of railing that a worker can maybe move out of the way once the door is open. They can move out of the way so that the truck can back in and do what they need to do. And then, when the truck is getting ready to exit, they can put the railing back up.
All right, final question, unless folks want to stay on later, but what defines a qualified person? What defines a competent person?
Excellent. So a qualified person is someone with a recognized degree, certificate, professional standing. They also have extensive experience in the field of work. They have the ability to solve and resolve problems. Okay, that's a qualified person. The competent person is someone that has the ability to recognize unsanitary, unhazardous conditions, and they also have the authority from the employer to eliminate or reduce or mitigate those hazardous conditions. So one person has authority, the other person just has degree, certificate, professional standing, and they have knowledge, experience. They cannot make decisions. One is a decision maker, the other one's not. That's a very important person in construction. I always stress this. Anytime you got a program in construction, assured equipment grinding conductor program, fall protection plan, any type of program that's a set, it's always going to say shall be implemented by a competent person. Shall be implemented by a competent person. That's a very important person that the employer has to designate in construction because they're a decision maker. It's like not everybody's not a decision maker. The competent person is. That's why compliance officers always ask for who's the competent person when they show up to a work site, because they want to know who's the decision maker.
Got it. Great answer. Christy, do you have any that I missed?
Sean, there are a lot of actually questions that just came in at the end, so I'm not sure if we'll be able to get to them. So I've copied all those. We've taken your questions. If we're able to get those answered, when we submit the recording and the slide presentation, we'll go ahead and send those answers along with that.
All right. Well, one of the ones that I saw, if you want to answer this one because it's relevant to all of us on the call, it says lots of fake OSHA training online. How do you sort what's good from the bad? It says from chaff from the wheat. I want to make sure my staff get training that actually meets OSHA requirements, basically. So how do you know what's good and what's not is the question.
Well, the number one answer I'm gonna give is that, you go to an OTI, an OSHA Training Institute education center, because with that, you're gonna make sure you have that information there. When you're looking at any type of online based training, I would check where they're getting their certification from and just do a nice little background research on that to see, who's the qualifying body behind this particular training. But I would just recommend going through the OSHA Training Institute education centers, because you're gonna get the real deal there.
All right. I think that puts us at time, a little bit over. Appreciate Aaron, everybody on the call, everybody joining us. Look for more webinars as they're coming up. We'll probably have one put together for October is the plan. If you're on this list, if you've registered, we will get in touch with you and let you know. Thank you, everybody, for joining. Have a great day and a great weekend.
Thank you so much.